Well, hello there, my little distance learning chemists. Today we're going to look at, or in this video, it might not be today, it might be here tomorrow, I don't know. But what we're looking at is lesson 90. Lesson 90 gets us to start thinking about precipitation reactions. The basics of a precipitation reaction is that you take two chemicals that are in solution, couple the ions from each solution come together, they form a solid, and they fall out. That falling out of the solution is called precipitation. So, essentially, for success in this particular uh, lesson, you have got to familiarize yourself with the table on page 459. It's up at the top. Learn how to read it. Basically, you've got a list of positive cations going up and down on the left-hand side of the table. And then across the top, there's a list of negative anions. And what it's trying to show you is that when they come together, they're either going to do one of two things. They're going to be soluble, which means that they do nothing. They stay hanging out in solution. They don't precipitate, or they are non-soluble. Non-soluble means that they get together. When they get together, they're going to precipitate out, and they are going to fall to the bottom of your jar or your beaker, whatever you're mixing it in. Eventually, it may not happen right away. You're going to see a cloud for a while, but through time, gravity is going to pull those very light, very fine particles to the bottom of the beaker. So again, the N means non-soluble in that table. They're going to form or precipitate. The S in the table means that it's soluble and it is not going to create a precipitate. It's going to remain in solution. So anyway, the chem catalyst for this particular chapter lesson asks us to think about the reaction that creates kidney stones, or one of them. And basically, you can get the chemicals in your body from a number of processes. A lot of it has to do with the foods we eat, the things that we drink. Most of the time, because calcium oxalate is not super non-soluble, we can pee it out. But when we get to the point where we don't drink enough water, oftentimes it has the opportunity to start clumping together. When it clumps together, because you're not flushing your system really well with lots of fluids, that clump turns into a stone. And those stones can become very painful when they get into the smaller tubules that lead out of the kidney, and you get really bad back pains in your lower back, and it just feels miserable. So anyway, the idea here is we are taking calcium chloride, which is in solution, again, comes from some of the foods we eat. We have sodium oxalate, which is in solution, again, from stuff we eat. And eventually, those swap partners, again, through a double displacement reaction. And the oxalate goes with the calcium, the chloride goes with the sodium. And what we get are two sodium chlorides that remain in solution and calcium oxalate. And the calcium oxalate, again, becomes a solid and precipitates out. So, what is really happening here? You have to take a look at something called the complete ionic equation. Again, your book talks about this in this lesson. But the idea is that calcium and chloride do not hang out together. Because they are in an aqueous solution, they are hanging out as their ions. They're not holding hands, they're not stuck together. They are individualized as their ion. And so when we look at the calcium chloride, it breaks into calcium 2 plus ion. Again, that should be aqueous. I forgot to write that there. And you get two chloride ions. aqueous, floating around by themselves. Then the sodium oxalate, you get 2 sodium ions there, again, aqueous, floating around, and you get the oxalate 2 minus ion that is aqueous. And then basically what happens is the sodium and the chlorine don't do anything. They just still hang out in solution, floating around, oblivious to what's going on around them. But the oxalate and the calcium get together and they actually react into what we call calcium oxalate. That is the material that creates that kidney stone. And so if we look at this complete ionic equation or complete ionic reaction, whatever you want to call it, what we see here is something called spectator ions. Spectator. If you're a spectator, what do? You just sit there and you watch. Ooh, go Giants, go Raiders, go whatever my team is. Okay, you just watch. You're not participating. You're not doing anything. So we call them a spectator ion. And so spectator ions here are the sodium and the chlorine. That's sodium 2 plus there. That's chlorine ion minus there. There's 2 of the chlorines there. There's 2 of the sodiums there. They're not doing anything. So basically what we do is we can cross these spectator ions out of the whole kit and caboodle. And what actually reacted or what actually happened in the whole thing is what we call the net ionic equation or net ionic reaction. And that is that the calcium 2 plus aqueous ion comes together with the 2 minus oxalate ion aqueous. And that gets together and makes the calcium oxalate, the material that makes those kidney stones. Then our check-in says we've got potassium sulfate solution and lead nitrate solution. When we mix them together, what happens is we get a precipitate. Then they say, well, write a reaction and tell what the precipitate happens to be. So if we take a look at this, again, you could go into the complete ionic reaction if you want, but if you just think back to, I think it was chapter 13 when we were doing these double displacement reactions. Again, we switch our dance partners. So potassium here has got to go over with the nitrate. The lead has got to go over to the sulfate. What happens is we end up getting 2 potassium nitrates. Again, they remain in solution. They would be spectators. We could knock them out if we were doing our net ionic equation. And what we're left with then is that the lead and the sulfate gets together. Now, how did I know that this would become a solid? Page 459. If you look at page 459, you go up and down on and find the lead. Then you go across the top and you find the sulfate. And where they meet, there's an N. That N tells you that they cannot be soluble. They are going to precipitate out and go to the bottom, and that's your solid. So, again, any questions? Lesson 90. You got it. T. Wyrick at auhsd.net. So I hope I don't have to keep writing that, but I'm going to. Maybe you'll start saying it in your dreams and you'll email me more. I love to hear from you guys. Had a couple of good questions last week. Keep them coming. I don't mind answering them. I might not get to you right away, but soon after, at some point, I will get to you. Have a great day. We'll check you out soon with another one.